In the name of God, in this film, we will teach you how to record single unit by the device eLab and the software eProbe. For this, you should first have the screen special for the single unit protocol open. So, click on Template. If you already have the protocol, you just select it. Otherwise, you press Ctrl N. You can save a new protocol with a name. I will name it Spike. They will come up all empty. Then I press Ctrl E. This column will open. The things we need: scope. You left click on it, then you right click on the empty page. You take the open window to the corner, then maximize it as much as you want. eSorter for sorting our recorded data. eTrace CB. We do the same with this. Then I press Ctrl E again. The column will close. Now we have three features: scope, eSorter, and eTrace. We also have four menus at the top: template, device, tools, and help. If I now close the software and open it, our last template is there. Or if it weren't there, you can reopen it through template. The other menu is device. The first option is eDevice. As you want to use the device eLab, you choose this option. The number at the end is the code assigned to your device, which may differ each time, so that's not important. The other option is eDevice 2. If you want to simultaneously have stimulation too, you choose this, otherwise you set it to none. If I click on Scope, you can see the noise signals. Now I'll stop it for the settings of each part. The first was the scope. I right click on it. Data stream for channels. Our device is 2-channel. Channel 1 or 2 is being used. The next options are VD and TD. VD is the scale of horizontal and vertical coordinates, as you know better. For single unit, we set it between 50 and 100 microvolts. Time division depends on your own recognition. I sometimes set it to 5 milliseconds and sometimes 100 milliseconds. Accordingly, the display will change. HPF and LPF are high-pass and low-pass filters, which are set between 300 for HPF and 5 kilo and sometimes 10 kilohertz for LPF in single-unit recording. So frequencies in between will pass, and those lower than HPF and higher than LPF will be filtered. The other option, which is very important, is signal. We set it to spike mode. The other settings are not related to eLab and single-unit recording. There's the theme setting, by which you can change the color up to your own recognition. I run scope again. The signal is moving now. When I set its voltage division 50 microvolts, the signal becomes larger. Or if I change time division from 5 milliseconds to 100, it displays it more intensely. The horizontal scale of each square is 100 milliseconds, and the vertical scale is 50 microvolts. I stop it. Then the bottom window, which is very important. This part, which is for your stimulator, you're not involved with this, always leaving it off because you don't have any stimulation. This one is also unimportant as it is the amount of the current stimulated, as it's basically off. Important here is the recording file name. When you click on this, you can exactly say where it will be saved and under what name. For example, in drive D, the folder signal with the name spike-test1. Then you save it. The file we're saving should be set in terms of timing, how many seconds to save. Timing differs from case by case. If you want to have long-term recordings, it might be from 15 minutes up to 1 hour, depending on the type of your test. For example, you might have one recording at the 20th minute of which you want to apply some medicine, then have the measurement. Otherwise, you might want to finish a 15-minute test, then apply the medicine, and finally record again. These two will lead to a single whole file or two separate ones. That is up to the Sciencebeamer. According to your research, we may also guide you on the best timing. Now, I open the Design protocol. Here, we see stimulation parameters. You're not involved with this top section. Then, here we have recording parameters. Here, we see trial number. 1 means the test will be done once only. Trial period defines the test period. For example, if we want it to be 10 minutes, it is 600 seconds. So we add 3 zeros to make it milliseconds, making 600,000 milliseconds. Recording time says how much of the test period you want to record. As we want all of that, so it will be the same. We then save all this. We name it P10min. Now I make and save another protocol, which is 20 minutes. Then I select either of the protocols already made through this button. If I click on Scope, no data is saved. You fix the electrodes in place to see if the signal is fine or not. Now I return the time division to 5 milliseconds. Now we're getting the noise of the city power as it's not connected to anywhere. Now I stop Scope. Once I start it, data is saved as spike-test1. Now I'll start. It's written here, save mode is running. Elapsed time is exactly defined. So right at the beginning, you define a name for the file. Once you stop, the data has been saved under that name, but when you want to record again, you should change it so that the previous file will not be replaced. Well, the next section is the sorter. I'll run the scope again. The sorter is supposed to separate some spikes from this signal. Our sorter is based on the window discriminator method. We want to separate the spikes with a higher point by the 2 lines of the scaling window. It is different from the clustering, which offline sorters such as Plexin do. You can take the data after acquisition offline to any software which does sorting, as they give you more options, or you can use the optional sorters companies, such as us have. But in an online way, that is, upon recording, you can only select the recording by this window method. I right-click on it. I'll open an offline file. I have now opened a file upon which I want to do clustering. I right-click for the clustering settings. First is written channel. It must be right. If this scope is 1, this one must be 1 too. There is an audio, which gives you the raw audio of the signal. This is the voltage division for the sorter. Be reminded that this recording is multi-unit. It is recording 4 or 5 neurons. They're mixed up here. When you stop it, see, this is a neuron peaking here. Again, peaking, so forth. All these peaks are the same, but another neuron is peaking at this level, smaller but with higher frequency. You can distinguish each neuron by its peaks and valleys. Now, how can we separate it? If we click on the right at the top of this window, a red line will be drawn. If you click this side, a yellow one will appear. This sorter will separate each spike, which is between the red and yellow lines. The higher you take the lines, you can select the higher one. This low part, which is raw, includes all the neurons mixed up. They're summed and shown together. Now, we have selected from this unclustered recording the spikes within this area between the 2 lines. The voltage division of the sorter is not necessarily the same as the voltage division of the scope. It is for making the display more suitable for your job. 10, for example, is too big, 100 too small. We usually set it to between 20 to 100. But if you have a very sharp case, you may set it to 250. Now, we are selecting the neuron with a frequency around 12. This number is the selected neuron peak frequency. This one is the second neuron. You can do the same over a second neuron, for example, a smaller one. We should set the line so that it selects only one neuron, rather than the noise, for example. Otherwise, it will be fake. Now, we want to draw the PSTH of the neuron. Here we have bin size. I set it to 1000. If you see, it is making 1 bar per second. PSTH stands for peristimulus time histogram. For example, when this is 5, it makes a bar correspondingly. When the peak frequency becomes 8, the histogram makes a higher bar. Suppose that you're having a record of 20 minutes at minute 10 of which you have a medication. The important point is that after several seconds or minutes, the peak frequency becomes less or more. You can see this in the PSTH, and you can understand the medication has influenced with what latency, what consistency period, and its expiry. The bin size unit is millisecond. So when we set it to 1000, it actually equals 1 second. So each bar represents 1 second of the neuron peak frequency. If I make it 10 seconds, the display will become more intense. When set to 100 milliseconds, you can see the peaks with higher resolution. We usually use 1000 milliseconds in long-term recordings. In addition that the analysis will be easier as the time unit of the neuron peak frequency is second.